Good morning, everybody. Welcome to the digital system and microcontroller subject. Last time we have seen how to design the combination circuit, sequential circuit, and we have also simulated on this rotate simulator as well as the CPLD kit. Now go to this next part of this subject is microcontroller. So today we go to this introduction to microcontroller. So this topic includes introduction of this microcontroller, then block diagram this microcontroller as well as the pin description of the 8051. What are the different registers are used in this microcontroller, how the memory is mapped is done. Similarly, how the stack is handled in 8051, what are the different types of IO port programming, what are the different types of timer used in the microcontroller, and what are the different interrupts in the microcontroller. Now today we see the only introduction and this introduction of the microcontroller. Now microcontroller, microprocessor. So they looks like similar, but what is the difference between these two? So microprocessor is the core of the computer system. So every electronic gadget or the communication system, every digital entertainment systems, portable device are they controlled by the microprocessor itself. So microprocessor, microcontroller, it divides in two parts. So it is become hardware, and the hardware is controlled through the software. Now what is the hardware? Hardware, it is actual interface with the real world, and software which supports to handle this hardware. So together with hardware and software become the embedded system. Microprocessor and microcontroller. Now see, there are various units. Now central processing unit. Now central processing unit process the data which is available in the memory. The input devices. The input device is nothing but the input to the microprocessor. It may be mouse, it may be keyboard, it may be switches. The input from the various sensors. These are the input. Now output goes to various devices like display, printers, 7-segment display, LED indicator. These are outputs. So input is taken from various devices, output is also given to the various output devices. Whenever there is a microprocessor or microcontroller, it have address bus and data bus. So data bus contains the data, address bus addresses the address of the particular data, or it addresses the particular data. It is stored in the, that is, the data is stored in the memory. Memory may be RAM or ROM, read-only memory, or write-only memory, random access memory or read-only memory. Similarly, for timer, having timer 0, timer 1 are the timers for timing purpose. Interrupts is nothing but somebody should interrupt it. So interrupts, it is one of the mechanism to interrupt the routine. Similarly, for the communication with the outside world, some ports are necessary, serial port or parallel port, or such type of pins are available in the microcontroller. Now see what is the microprocessor first. This is general purpose microprocessor. Now look at this. So this is our central processing unit. Now central processing unit, it is itself, it doesn't contains a memory. It is having RAM, ROM, I/O ports, input-output timer, serial I/O ports. These are the outside of this microprocessor. It contains some general purpose registers, timing blocks, interrupt routines, and serial facilities. These are available in the central processing unit. But the outside world data is available through the output port. It may be stored in the RAM or ROM, and it is processed. The data which is available in the ROM, it is processed to this central processing unit. Similarly, the data is again available at the output port. Input may be taken from the timer, it processes here. Similarly, for the communication with the outside world, serial port is available. So this is a general block diagram of this microprocessor. That means it is a CPU. It looks like central processing unit, but it doesn't have any RAM, ROM, I/O on chips. It is not available on the chip. It is outside the chip. So 8085, it is one of our microprocessor. Now see microcontroller. Now look at this previous. So it is a central processing unit, all in outside the what. Now look at this CPU. That means this is a single chip. Inside the single chip, central processing unit, RAM, ROM, I/O port, everything is inside. So that means a processor inside, that is computer inside the chip. It is computer inside the chip. So on chip RAM, ROM, I/O ports, etc., which is available on the microcontroller. So that is the basic difference between this microcontroller and microprocessor. So for microcontroller, there is no need to I/O ports, external I/O, external RAM, ROM, similar timer, and serial I/O. But in case of microprocessor, we need these external devices. We need attach external devices. Similarly, for memory mapping, we need a certain mechanism. But for this microcontroller, no external mechanism is required. So it is a computer on a chip. That is our microcontroller. Now what is the difference between microprocessor and microcontroller? So microprocessor, it is a standard CPU is standalone. RAM, ROM, I/O timer are separate. But whereas microcontroller CPU, RAM, ROM, timer as well as all on a single chip, it is different. It is outside the chip, all the devices outside the chip, outside this processor chip, and inside the processor chip. Now designer can decide the amount of ROM, RAM, I/O ports in case of microprocessor. But for the microcontroller, all I/Os are fixed, RAM, ROM size is fixed. If you want a bigger memory, then he has to choose a processor, the microcontroller with higher memory handling capacity. Similarly, we require external RAM, ROM, so it is expensive. So different I/O devices, power consumption is more in case of this one. But for the microcontroller, wherever space required is less, power consumed is also less, similarly cost is less, because everything is inside, no external devices are required in case of microcontroller. Whereas microprocessor, it is general purpose microprocessor, whereas microcontroller is single purpose, microcontroller. Now embedded system means a processor is embedded into the applications. So an embedded product uses microprocessor or microcontroller to do one task only. It does only one task, whereas the computer does a many tasks. So this is the embedded system, and it is standalone system, and it contains the code which is born in the ROM. So examples are printer, keyboard, video games, and player. Now recap this. What you have done, what you have learned today. What is a microprocessor? What is a microcontroller? So next time we see the architecture of this 8051 and detailed plan of the 8051 microcontroller. Thank you.